Now that we know how to find common denominators, it's time to learn how to add algebraic fractions. No surprise, it's based on how we do it with arithmetic. If I have a common denominator already, in order to add these fractions, I say 2 sevenths plus 3 sevenths is 5 sevenths. I add the numerators, the denominators stay the same. So I'm going to start with a simple example, 3c over 16 plus 5c over 16. And with each of the examples I'm going to do, I'm planning to point out the different things that are particularly tricky or maybe booby traps that you have to watch out for. I can see that I have common denominator 16, so I need only to add the numerators. That gives me 8c over 16. But the first important part, and this really plays out throughout every type of addition and subtraction problem, you always need to factor and reduce. Every problem. It's easy to forget. That's true with arithmetic as well, but we can see that 8 goes into 16 twice, so our final answer is c over 2. The next little tricky thing is really going to drive home one of the big reasons why we always put our polynomials in parentheses. The problem starts out 5x plus 4 over 10 minus 3x minus 8 over 10. Now you can see already that you have a common denominator, so it's just a matter of adding, or in this case, subtracting the numerators. I want to put my polynomials in parentheses, and I also urge you to take a minute to just, over the common denominator, show what you already have. In this case, it's 5x plus 4 minus 3x minus 8. Once you have this, it's easier to see what you need to simplify in the numerator. That means get rid of the parentheses, 5x plus 4. And this is the reason why it's important to put your polynomials in parentheses, because this is negative 3x and positive 8, because this negative 1 is distributed, or it's the opposite of 3x minus 8 over 10. I continue by combining like terms. That gives me 2x plus 12 over 10. And as always, I need to make sure that I am in lowest terms. I can factor out the GCF here. And that's important because the final answer is x plus 6. Let's look up here at what many kids would do if they didn't put their polynomials in parentheses. I'm going to show you, and then I'm going to cross it out. 5x plus 4 minus 3x minus 8. If you don't have it in parentheses, chances are you're not going to notice that when this entire quantity is subtracted, the 8 becomes positive. If you leave the 8 negative, you're wrong. So let's just erase that thought. It's a big reason why putting polynomials in parentheses helps you in all kinds of problems when you're dealing with polynomials and fractions. The next example brings up something that I referred to yesterday, but now we're going to flesh it out. The problem is 2 over x minus 3 minus 7 over 3 minus x. Of course, we're going to put our polynomials in parentheses, and it might look at first like these have no common factors, because they don't exactly. However, they do have a relationship. I think most of you in class remembered when we talked about this, that x minus 3 and 3 minus x are opposites of each other. So if I take the opposite of 3 minus x, it is x minus 3. The reason why that helps is I can rewrite these. Rather than doing the whole what's missing business, I can just rewrite these as 2 over x minus 3. I'll take the opposite of that, and that allows me to write it as x minus 3. I have not changed the mathematical value, and yet I have a very simple thing to deal with at this point. That when I add my numerators, I get 9 over x minus 3, And if I keep them in parentheses, I will not be tempted to cancel the 9 and the 3. They cannot be canceled. Never cancel anything that is part of a polynomial. And that makes it easier to see. Here's another reason why P really helps. You can see. I think you know, if I plugged in a number for x, a random number, let's just say that x is 4. 9 over, well, actually, let's make it 5. 9 over 5 minus 3 is 9 over 2, and that doesn't reduce to 1/5, or 3/5 is what that would be. It's mathematically not true. And I think there are lots of you who can see that, you know it, but visually it looks like you should be able to cancel them. In order to avoid that, put your polynomials in parentheses. So, the important thing here is when you have these opposites, you want to change your sign and also change the order of the terms. Okay, so moving on. We're going to do one that doesn't have a common denominator. Now, as we practiced last night, what you want to do is factor the denominators, see what's missing, add that to the collection, put that in the collection of factors, and take it from there. Some of you can probably tell what the least common denominator of 4 and 18 is, but in case you can't, you want to look first at this one and say, what's it missing that one has? And that's 3 squared. 3 squared is 9. So I'm going to multiply the top by 9. This one is missing 2. So I'm going to multiply the top by 2. I'm going to put my long fraction bar here. I'm drawing some wavy fraction bars here. And without doing any math, I'm just going to write out what I've got. Over, this number is 36. 4 times 9 is 36. Some of you may be tempted to try to cancel this 9 and the 36 as long as there is an addition or subtraction sign that is not inside of the grouping symbols, the parentheses of a polynomial. You cannot cancel. So don't cancel yet. Instead, you need to simplify. 9a minus 10 minus 12a over 36, which is equal to, sorry, that's 24. I made a So 9a minus 24a is negative 15a minus 10 over 36. And you do want to always factor and make sure that nothing can be canceled. In this case, it's not going to be cancelable. But when I have a negative term here, I usually like to factor out the negative. So I make it negative 5 times 3a plus 2 over 36. Nothing can be canceled, so that is our final answer. Another one, denominators that are different, however, they're all they're all monomials, so it's a little bit easier. 3 over 2x minus 1 over 8x squared. Well, I don't think anybody here really needs to factor this out. It's clear that this one is missing 4x. So now I have 12x minus 1 over 8x squared. The only possible thing that might be problematic here is if you thought that the 12x and the 8x could cancel out. But if you put your polynomials in parentheses, you will not be fooled by that. We're getting to some of the harder ones, though we're going to save the truly difficult for tomorrow. And here's the example that I want to give. It's 3 over y minus 6, put my polynomials in parentheses, minus a over, no problem, 3 minus 6, y minus 6, 3 over y minus 6, and this one is 1 over y. If it's in parentheses, you're much less likely to be confused that this is missing a y and this is missing a y minus 6. Often kids think this is only missing y minus 6, but it's missing the entire factor. Okay, I want to put this all over one big line without doing any computation. 3y minus 1 is fine. You can have it or not. I think in this case it might actually help. Y minus 6 over y times y minus 6. Again, when you're doing subtraction, it's very helpful. If I didn't have this one here, and I didn't use my parentheses, I would be very tempted to just say 3 minus y minus 6. But if you put it in the parentheses, like we are here, it's easier to see that what you have is 3y minus y plus 6. So P, especially with subtraction. Especially with subtraction. Because it messes with the signs if you don't have things in parentheses. This is y times y minus 6. When I combine those like terms, I get 2y plus 6 over y times y minus 6. Even though this isn't going to reduce, I do think it's worth always just being in the habit of factoring to see if you can reduce. In this case, there are no factors that cancel out because we have to cancel this entire thing and this entire thing. And remember, here's another situation above. When I'm talking here, I can't cancel these yet because of this subtraction sign that's not inside of parentheses. I have to first simplify and simplify here and then factor, and it is not reducible. So, summary, the steps that I've given you are, I'm going to just share. That's not what I wanted. From the photo roll. Okay, here. And that's it. At least for today.